In this video, we'll be looking at angles in circles and in particular the fact that the opposite angles in a cyclic quadrilateral add up to 180 degrees. So when we talk about a cyclic quadrilateral, we refer to a quadrilateral having all four vertices lying on the circumference of the same circle. So if we are facing this situation, then if this angle here is theta, then the opposite angle will be such that the two add up to 180, so it must be 180 minus theta. And similarly, if this angle here is phi, then the opposite will be 180 minus phi. Now, looking at some simple examples, we need to find x here, we need to provide reasons. So we notice that we are indeed looking at a cyclic quadrilateral, and therefore the 77 and the x should be adding up to 180. So 77 plus x is equal to 180, which means that x is 180 minus 77, and therefore x turns out to be 103 degrees. The reason here will be that opposite angles of a cyclic quadrilateral add up to 180 degrees. In the second example, we need to find the angle y. So I will start by labeling this angle here z, because z is opposite the 105. So we can start by saying that z is 180 minus 105, which gives an answer of 75 degrees. And the reason is, of course, that opposite angles in a cyclic quadrilateral add up to 180 degrees. I'll go back to my diagram, update the z with the 75, and then we notice that z and y are angles on a straight line, so they should be adding up to 180 degrees. So y is 180 minus 75, which works out to be 105 degrees. And the reason given here will be that angles on a line add up to 180 degrees. In the first example here, we need to find the value of x. We notice that we're looking at a cyclic quadrilateral, and we also have parallel lines here. So I could actually start by saying that I will call the angle down here on the left to be theta. And we notice that the theta with the x are interior angles, and therefore they should be adding up to 180 degrees. So we start by saying that theta is 180 minus x, and the reason is interior angles. We then proceed by saying that the 180 minus x, the theta that we found here, together with the 2x minus 70, should be adding up to 180, because opposite angles of a cyclic quadrilateral add up to 180 degrees. So we have that 180 minus x plus 2x minus 70 is equal to 180. This gives me that x plus 110 is equal to 180, and therefore x is 70 degrees. We need to provide reasons, so we've got that opposite angles of a cyclic quadrilateral add up to 180 degrees. In the second example, we need to find the angle y here. So I will start with the 100 here. I will call the angle within the triangle here theta. So we can start by saying that theta is 180 minus 100, which gives a result of 80 degrees. And the reason is that angles on a line add up to 180 degrees. And then we can proceed in finding the opposite angle in this cyclic quadrilateral, this one here, which I will call phi. So phi should be 180 minus theta, so it's 180 minus 80, which gives an answer of 100 degrees. And the reason is, of course, that opposite angles of a cyclic quadrilateral add up to 180 degrees. Now, to find y, notice that the triangle here is isosceles. The two sides here are given to be of the same length. And therefore, to find y, I will do 180 minus 100 over 2. This gives a result of 40 degrees. I need to justify my work. The 180 is coming from angles in a triangle adding up to 180 degrees, and the over 2 is coming from the fact that the angles at the base of an isosceles triangle are equal. So to prove this circle theorem, I will start by considering a cyclic quadrilateral ABCD. We're going to call angle BAD here to be theta, and similarly BCD to be phi. And we are trying to prove that these two angles should be adding up to 180 degrees. In order to proceed with the proof, I will start by considering the center of the circle O, and I will draw the radius from O to B and the radius from O to D. Now we know that because angle at the center is twice the angle at the circumference, then if this is theta, this angle here should be 2 theta, and similarly the angle BOD, the obtuse angle, should be 2 phi. So BOD, the obtuse angle, is equal to 2 phi, and similarly the BOD, the reflex angle, is 2 theta. Then we can just notice that 2 phi plus 2 theta is equal to 360. We've got angles at a point which we know add up to 360, and therefore we have that phi plus theta must be 180 if we divide throughout by 2, and therefore we have just proven that angle BAD plus BCD is 180, which means that opposite angles of a cyclic quadrilateral add up to 180 degrees. Thanks for watching. If you found this video useful, please like it and subscribe to our channel. You can also leave a comment below to tell us what you think.